Hi there. So our third video today is just going to go over strategies in finding limits. All right, so we kind of have this flow chart to try to sum things up for you. So the first thing we want to do is try to evaluate the limit directly. So that's called direct substitution. Okay, so we're going to substitute a number into A. So here's what could happen. We could get a number over 0. And when that happens, we get something called undefined. Remember, we said it's all fun and games until you try to divide by 0. It just can't happen. Now, the one thing we haven't stressed, which I want you to put in your notebooks, is that most likely 99% of the time is going to result in a vertical asymptote. Okay, so take a moment and I just want you to write down a number divided by 0 is going to get you a vertical asymptote 99% of the time. We could plug it in and just get a number out and we're done. Or we could get 0 over 0, which we said has a very special name called indeterminate form. Now that indeterminate form means you're not done. So you'll notice the flow chart stopped with these two because we had answers here. Indeterminate continues on because, like I said, we're not done. So here's what could happen if I follow this indeterminate place. You could use factoring, which we talked about. We could use conjugate method, which is going to happen when you see the radical. We could use the trig identities, the Pythagorean trig identity. And then the final one we talked about was that complex fraction, which kind of falls under factoring. I just had titled it something different in the previous one. But again, these are the three main things that we're going to do, and then we'll end up with an approximation at the very end. So 2 key points. Key point number 1, direct substitution is the go-to method. Okay, no matter what, our first move is always substitute indirectly. If we get 0 over a number, our answer is 0. If we get a number over 0, it's undefined and probably a vertical asymptote. If we get 0 over 0, that's our indeterminate. And again, use only other methods when direct substitution fails. And again, I just want to be clear, it fails when you get 0 over 0, when you get indeterminate. Key point number 2, there is a big difference between 0 over a number over 0, and 0 over 0. Make sure you understand each of these. And again, I feel like I'm saying the same thing, but it's really important we understand 0 over 0 indicates you are not done. It is indeterminate and you need to try another method. So these were just some sample. This happens to be a multiple choice question, but I just want to go through and talk it out. We want to find the limit as x approaches 4 of g of x. So what happens when we try direct substitution? So take a moment. You just obviously, I think just copying this part down and substituting in the 4 is enough work for this. You don't need to copy all the choices down. But take a moment, pause it, plug in your 4, and let's see what happens. So I've got my work off to the side there. I have 4 minus 3 is 1. This becomes 9. So the square root of 9 is 3. 3 minus 3 is 0. So again, it's all fun and games till you divide by 0. I would say the limit does not exist. And again, I just want to stress it's probably an asymptote. And I'm going to even throw in the word vertical to be more specific there. It is probably a vertical asymptote. Number 2, what happens when we try direct substitution again, when we take the limit as x approaches 0 of h of x? So again, I'll pause it, plug it in, see what happens. All right, so I've got 1 minus the cos of 0 over 2 sine squared of 0. As I go to evaluate the cosine of 0, I'm just going to the graph. I'm finding 0, so the cosine of 0 should be a 1. And then I need the sine of 0, and I'll square that answer. So I always do the squared at the end so I don't get confused. I evaluate, do any squaring or cubing, whatever. So the sine of 0 happens to be 0, so I'm going to end up with 0 over 0. So again, I just want to make a note. This is indeterminate. Which means I need to continue, probably using a trig identity. And hopefully you see that trig identity right here. Sine squared comes from that Pythagorean theorem. Sine squared plus cosine squared, theta equals 1. So to get sine squared by itself, I would just subtract that cosine squared over. And I can make that replacement there. Justin tried to find the limit as x approaches -1 using direct substitution. He got 0 over 0. For Justin's next step, which method would he apply? So as I'm looking at this fraction here, I noticed there's no radicals. So to me, conjugate method, I'm going to cross off right away because I don't see any radicals. That's the only time I'm using that method. I think option C is a little obvious. There's no trig function, so I know I'm not using that. And hopefully you realize that you can factor this. That's just a simple trinomial. You can factor and cancel or divide those out. So I think I would go with choice A in this case. Fen Yang's teacher gave him a flow chart below and asked him to find the limit as x approaches 3 of this function here, which apparently I don't have the rest to. So let's go ahead and approximate the x approaching 3. So f of 3 is equal to 2 times 3 is 6 minus 5 is 1 minus 1 all over 3 minus 3, which is going to get me a 0 over 0. So probably similar to the previous question, what would be the next step? So we did direct substitution. We're getting indeterminate, okay, which means we have to try something. So I'm hoping the dead giveaway is that you see this radical in here. So I hope you're going to apply that conjugate method. So just for fun, I'll work this one out. And I just want to remind you, you're always going to do the conjugate of the radical. So I'm going to multiply both top and bottom by the square root of 2x minus 5, this time plus 1, to both, again, the numerator and denominator. Remember that bottom, a radical times something that's not, we're not going to mess around with. We're just going to rewrite it. And on the top, we're actually going to FOIL that out. So again, I'll run through that FOIL. Any radical times itself as I multiply these firsts together. I'll wrap this up in parentheses. So multiplying that times that is just itself. So that's 2x minus 5. Remember, this is going to be plus that radical, and this is minus that radical. So they just cancel each other out. They're gone. And then negative 1 times positive 1 should get me a negative 1 or minus 1 on top there. So if I clean up that numerator, it looks like that's 2x minus 6 on top. And again, you're thinking, well, that's not canceling with anything, so maybe I didn't do it right. But of course, you can pull out a nice, easy GCF there. I can pull out that 2, and there's my x minus 3. So my x minus 3's will cancel. Sorry, I'm writing backwards. And I'm going to get 2 over the square root of 2x minus 5 plus 1. And then I can reevaluate that limit for 3. If I plug in a 3 on top, I still get a 2. 2 times 3 is 6, minus 5 is 1. Square root of 1 is 1. 1 plus 1 is 2. So I would say I get a final answer of just 1. Okay. So we're going to have some questions for you to play with. I think the link is going to send you to a Khan Academy that you'll see on the homework side, and you can kind of go through and practice their questions. I don't believe you have to log in, but you can always use your school account if you have to.